Okay, in the previous lecture, in the previous video, we have demonstrated that now we can make anisotropic deposition and etching. But at the end of our previous video, I told you that my implementation is quite inefficient. So maybe you remember that it took about more than 2 minutes to perform the simulation of a relatively small one. So, so I told you that I would improve the efficiency. So today would like to share the result of that efficiency. Now we have twice enlarged system like 42 by 35 by 150. Uh, yes, so now we have a lot more, almost or 10 times more points in our system. And yes, the procedure is the same. So make an mm, make a on epi structure. After that, make is the etching, patterning. Uh, yes. So then the difference is like this. So if we visit our region that 85, yes, actually there is a remaining uh, element. So it is not, they are not required any longer. So I just keep it. Here we have introduced another class called voxel, and this voxel just describe how our individual region looks like. Previously, uh, we remember every x, y, z index or for each element, but now when you visit this voxel, then now it has the component called as underscore element, and it is defined as vector of a map, and it becomes quite efficient. So by doing so, I made a relatively efficient implementation. Now let's just have a look at its result without explaining too much detail about my improvement. So here we have the build directory and make. So now you can see that there is AngstromCraft. So why don't you just start it? So please note that we have almost 10 times more points, and now FA is grown and etching is done. So why don't you just have a look at the final result of h.cg and s5. So in this case, now you can see quite a similar result. So if we just eliminate the bedrock, then you can see that this is the structure. So of course, when you show cubes, so you can see much more cubes are there, and by showing its color, yes, quite similarly here we have substrate and sacrificial layers and channels and capping layer. Only change is now we have much dense grid, more voxels in here. Yes, so and you have seen that although we have 10 times more points, however our execution time was even shorter than previous case. So yes, by improving the data structure, we were able to accelerate its uh, execution. Okay, so I see that now the code becomes a little bit more improved. So now it is time to talk about how can you implement this uh, un oh sorry isotropic doping. So anisotropic doping was quite easy because we were able to just search it from top of the system. But now, well, in this case, now we have to find out the boundary of our existing system, and based upon that boundary, we can just add or uh, remove one voxel. So that can be an implementation of isotropic deposition or etching processor. So I will work on it, and when I have the implementation, so I will share it with you in the next video. Thank you.